Okay, in question 2, we've got Amar. He's studying the flight of a bird from its nest, measures the bird height above the ground, and that's measured in terms of h, and then time in seconds for the first 10 values of t. And he finds the equation of the flight of the bird is equal to this expression here. And you can see this is analogous to a straight line. This is the equivalent of the variable x, so this will be the gradient and this will be the initial height. So values of t as they increase will take height away from the bird's initial height of 38.6. So in part A, we've been asked to interpret the gradient of the line. Well, the gradient of the line is negative 1.28, which means that the height will go down by 1.28 meters every second. And that's really the answer to the question. And that will get you the 1 mark available. And in part B, we're told that the product moment correlation coefficient between h and t is negative 0.510. And we're supposed to do an hypothesis test, testing whether or not there is evidence of a negative correlation between the height of the bird above the ground and the time during the flight. And we've got to state our hypothesis clearly, 5% significant level, and state the critical value used. Okay, whether there is or whether there is not negative correlation, our initial hypothesis should be that there is no correlation. And if we're to test for negative correlation, well, that means the correlation has gone less than 0. So our new hypothesis, H1, is that R is less than 0. So this is a one-tailed test. So what do we need for the table? We need the fact that our n value is 10 and the significance we're looking for is 0.05, which is the 5% significance level. And if we look those values up, we find that the critical value is plus or minus 0.5494. So therefore, using the negative option of this, we can say that negative 0.5494 is more negative than 0.510. So therefore, there is not enough evidence to challenge the null hypothesis, so it stands. And that R is equal to 0.510. So Jane now draws the scatter diagram from Amar's results, and she gets this array of points. With reference to the scatter diagram, state, giving a reason, whether or not the regression line that we've used up to now is an appropriate model. Well, it's fairly obvious that the model is a straight line, and this is not. So whatever words you choose to write will give you the 1 mark involved. So all that I've said is that the equation we've used up to now for h is a straight line and the results are clearly a curve. So no, it's not a good model. Part D. And here Jane suggests a new model where u is equal to t minus k squared, and that popped into this equation for h. Choose a suitable value for h to write Jane's model in terms of h and t only. In other words, get rid of k. So here are Jane's suggestions, and she is suggesting that these results fit these measured results more closely than the straight line does. So substituting her value for u into the expression for h, we get this, which is basically an n-shaped quadratic taken away from a value of h, which is 38.1. Now we've got to eliminate k. Now k is the point where this curve reaches a maximum, because k will determine the time which, when subtracted from the variable t, will cause this expression to go to 0, which means we're roughly at this point here on the graph. And from the plot, the maximum seems to occur where t is equal to 3.5. So this is the point which causes this expression to go to 0 and leave 38.1 as the maximum of the flight of the bird. So making that substitution, we get the final equation for h from Jane's model, 38.1 minus 0.78, brackets t minus 3.5 all squared. And that will be the answer to part D.